Hello students, welcome to this video. As far as today's video is concerned, I have selected the topic of coordinate geometry. In grade 9th, you have already studied coordinate geometry. As you know, coordinate geometry was founded by René Descartes. You have discussed the location of a point as far as a point is concerned on a plane. This point could be in space also. Let's see what all you discussed in grade 9th. You simply discussed location of the point in different quadrants, because you have the Cartesian coordinates. You have first quadrant, second, third, and fourth. Then points were given, and you were asked to locate their coordinates, because you know that taking help of the coordinates of a point, the x coordinate and the y coordinate, we fix the location of a point. This was put forth by René Descartes, who is the founder of coordinate geometry. Now, as for grade 10th is concerned, we'll take this coordinate geometry to a higher level. You will be given different points with different coordinates, and what all you have to study, we have to study the distance formula, the section formula, as well as the area formula. You have 3 simple exercises based on coordinate geometry as far as grade 10th is concerned. But let's try to get an overview of what this geometry is all about and what are the different types of geometries. I would like to give a little bit introduction as far as the geometry is concerned. Geometry is a branch of mathematics, as you know. It all deals with the shape and size of different objects. You might have studied in lower classes geometry, like the topics that we study in geometry, they are all about area, the volume, the perimeter, shape, congruence, symmetry, similarity, reflection, rotation, and so on. Now you have 2 main branches of geometry. One is the Euclidean geometry and other is the non-Euclidean geometry. Euclidean geometry, see, when we talk about geometry, we talk about Euclidean geometry. For so many centuries, we had only Euclidean geometry. Euclidean geometry is the geometry that is based on the assumptions and the postulates put forth by Euclid, who was a Greek mathematician somewhere in 300 BC. And those geometries which are not based on the propositions, based on the assumptions of Euclid, means Euclidean postulates, such geometries are known as non-Euclidean geometry, and coordinate being one of those non-Euclidean geometries. Now, coordinate geometry is also known as analytic geometry. The founder was René Descartes. What Descartes did, he made use of algebra. Using algebra, he studied geometry. He tried to study geometry taking help of algebra. Now, in coordinate geometry, we are all concerned with the coordinates of a point, because with the help of coordinates you find the position as well as the location of a point. That point could be on a plane, it could be in space. And it has wide applications as for different branches of mathematics are concerned. It's widely used in day-to-day activities. Now let's see what all we are going to study as for grade 10th is concerned, coordinate geometry. We have 3 important subtopics of coordinate geometry. One is the distance formula, which we'll be taking today. So you have one exercise based on distance formula. Then one more result is the section formula. Second exercise of this topic is based on section formula. And one more is the area formula. That's the last exercise. Let me tell you briefly what all we have to do as for these 3 exercises, these subtopics are concerned. As for distance formula is given, you will be given 2 points whose coordinates are given, and you are asked to find the distance between those 2 points. And as for mathematics is concerned, distance means the shortest distance. Distance between A and B, the shortest distance. So we have a formula. With that formula, we find distance between those 2 points. Now those 2 points could be the vertices of a triangle, they could be vertices of a quadrilateral or any polygon. Okay. Now, what about section formula? In section formula, you have a line segment, and you are asked to find the coordinates of a point that divides that line segment internally. It could divide it externally, but as for grade 10th, you have internal division. Means there's a line segment AB whose coordinates are given, and you have to find the coordinates of a point of division that divides it in certain ratio. Okay, that's all about section formula. Sometimes the ratio is to be found and coordinates of these 3 points are given. We'll go in detail. Then the last formula is all about area formula. In this area formula, you have a triangle whose vertices are given, or you have a quadrilateral, any type of quadrilateral, and we have a formula to find the area of that triangle or area of that quadrilateral. Now today my topic is entirely based on distance formula. I will derive the distance formula and we will apply it to the textual exercise, this exercise 7.1 of your NCERT textbook. So let's try to see what this distance formula is all about, and we will derive this formula
Take triangle POR.
taking help of the Pythagorean theorem.
Angle OPR.
Now I have 2 points, they are on a plane, and I have to find the distance between those 2 points. This is distance formula. Now this gets extended to if you have 2 points in space. In that case you have 3 coordinates, x, y and z coordinate. There also you apply the distance formula, but we are working for a 2-dimensional plane.
Because we need to find the measure of
So
OPR.
distance formula says, for example, I have a line segment whose endpoints are A and B. If coordinates of A as well as B are given, let me take coordinates of A as x1, y1 and coordinates of B as x2, y2.
And the measurement for angle POR we found was
So the distance between A and B as per the distance formula given is AB, which is same as BA.
Sum is equal to 180.
That is the positive square root of the difference of the x coordinates, x1 minus x2 whole square plus y1 minus y2 whole square. This is distance formula for 2 points which are on a plane. Now this could be rewritten as AB is,
Angle OPR.
if you write x1 minus x2, you could express it x2 minus x1 whole square plus y2 minus y1 whole square. Because we are aware of this fact that A minus B is never equal to B minus A. They are never, but if you square both of them, so A minus B and A minus B whole square will be equal to B minus A whole square. That's why I've used this result. x1 minus x2 whole square or x2 minus x1 whole square. So this is distance formula. So we'll try to derive this. Then we will apply this to the textual exercise. Now I hope you are aware of the coordinates. What does x coordinate mean and what does y coordinate mean? Let me recapitulate that. As for René Descartes, x coordinate is the perpendicular distance of a point from the y-axis, x coordinate. See, I will explain it this way. For example, I have a Cartesian plane, this is first quadrant. I have a point P, its coordinates are x, y. X coordinate is also known as the abscissa, as you know, and y coordinate is known as the ordinate. So what is x coordinate?
Measurement of 2 angles is given.
This x coordinate will be an integer. It's the perpendicular distance of the point from the y-axis. So this is x coordinate. And what's y coordinate? It's the perpendicular distance of the point from the y-axis. So this is y and this is x. Now this figure is a rectangle.
And third angle
so this length is equal to this length. That means this is also x.
Of the triangle.
So in short, if I have a point whose coordinates are x, y, I drop a perpendicular. This distance is x. This distance is y. Hope you understood it. See, let me take it once more. I have a point O, x, y is the first coordinate. For example, 3, 2, they are the coordinates of a point. So what does 3 mean and what does 2 mean? Simply drop a perpendicular. So this distance is 3, this distance is 2. Sometimes you call it run and you call this as rise. Run and rise. Now we'll apply that same logic to x1, y1 and x2, y2. Try to derive this result. Now these 2 points are on a plane. So I will draw the first quadrant, assuming that they are all positive. So this is my first quadrant, the Cartesian plane, first quadrant of the Cartesian plane. Now my coordinates are x1, y1. So if I drop a perpendicular, call this as m. So my result says this is my x1, this is my y1.
From this figure, you can
just now we
simply
studied
observe
this. So
that angle
x1
BAC
is the
and angle
distance,
both are
perpendicular
made
distance
on
from
the
the
same
y-axis and y1 is
Or
the
you can say
perpendicular
both
distance
are
from the
subtended
x-axis.
on the same arc.
Apply the same logic to
And
x2, y2.
by definition,
So if I
by
call
theorem,
this as n,
angles on
so
same
this
segment
distance is
are always
x2,
equal in area. Sorry,
this
angles
distance is
in
y2.
same segment are equal. So we can write angle BAC.
Now we have to find the distance between A and B.
is
Now
equal to
see what
angle
we do.
BAC.
We have a, it looks like a trapezium.
As
So
you
what I
can
do,
see,
I go to A and
both
I drop a
angles are
perpendicular from A
same
on
segment.
BN.
That's BAC
Let this be
and BDC.
AT, whatever you want, AT.
Angles.
Now, this figure is
Same.
a rectangle. That means this distance is equal to this distance and this distance is equal to this distance. That means this is y1. Mind it, this full is y2. So this is y1. And what is this distance? This is same as this distance, mn. But what is mn? My dear friends, mn will be, if you observe, what is mn? Mn distance is this distance minus this distance. That means on minus om. So mn is on minus om. So mn is on is x2 minus x1. So this distance is x2 minus x1. So same as this distance, x2 minus x1. So the base of this right angle triangle AT is x2 minus x1. Now what about BT? Observe BT. BT will be this full distance minus this distance. In simpler terms, it has to be y2 minus y1. So BT is y2 minus y1. So this distance is y2 minus y1. So you have a right angle triangle ATB. You are asked to find AB, the hypotenuse. Apply Pythagorean theorem. So in right angle triangle ATB, apply Pythagoras theorem. So when you apply Pythagoras theorem, you get AB square is AT square plus BT square. Now what is AT square? X2 minus x1 whole square. And what is BT square? Y2 minus y1 whole square. That means my AB is taking square root on both sides. So that is x2 minus x1 whole square plus y2 minus y1 whole square. So this way we have derived the distance formula. This formula, distance formula, is the formula that helps you to find the distance between any 2 points which are on a plane, provided their coordinates are given. So how we write it? This is the positive square root of the square of the difference between the x coordinates, difference of the abscissa, plus square of the difference of the ordinates, x1 minus x2 whole square plus y1 minus y2, or x2 minus x1 whole square plus y2 minus y1 whole square. Now we'll apply this distance formula to exercise 7.1. Let's try to see how many sums we are able to do as this video is concerned. So I'm moving on to exercise 7.1. Okay, let's write the formula so that we could use it. So this is AB, x1, y1, x2, y2. Distance AB is nothing but x2 minus x1 whole square plus y2 minus y1 whole square. Now exercise 7.1 of your NCERT textbook, question number 1. It says find the distance between the following pairs of points. 2 points are given. Let me take deliberately those coordinates where you have the negative coordinates. That is my question number 1, part 2. So question number 1, part 2. The coordinates are given as minus 5, 7. Minus 5, 7 are the coordinates of first point. Let me call that as A. Second point I will take as B, or you could take PQ as per your choice. Second point has coordinates minus 1, 3. Let's call this as B. If these are 2 points, join them. So you have to find the distance between A and B. How many units are these 2 points apart? So applying distance formula, you'll first write the formula. You'll write AB is equal to, do write the formula first of all, so that you get used to it. X2 minus x1 whole square, y2 minus y1 whole square. So AB distance will be square root of. Now my x2 is, see x1, y1 is for the first point. x1, y1, that means point A. x2, y2, point B. Now it's x2, so I go to the second point, minus 1, minus x1, but this also minus. So minus will make it plus. So you have to be careful about the sign. x2 minus x1 whole square plus y2, I will go to the second point, minus y1, that is 7 whole square. So AB is, so don't apply A minus B whole square or A plus B, because they are like terms. You could simplify them. 5 minus 1 is 4, square of 4. 3 minus 7 is minus 4, square of that. Some students cancel square with this, which is wrong. So this is 4 square is 16. This is also 16. That means 32. So 32 would be, could simplify it, 16 into 2. That means 4 square root 2. So distance between A and B, that means AB or BA is 4 root 2 units. Not square units, it's units because it's not area, it's length. Now, sometimes you have the variables like letters are there, A and B. Let me take that part also and explain you how you apply A minus B or A plus B there. So this was quite easy. We'll move to the next part. Coordinates are AB, comma, minus A, minus B. This is third part. AB, this is A, minus A, and minus B. Minus A and minus B. So this is point A, this is point B. What's the distance between these 2 points? So applying the distance formula, AB is equal to, you can write x1 minus x2 also, as I said, both are correct, plus y1 minus y2 whole square. So AB will be, x1 is A minus x2. But we already have x2 as minus A, so that will make it plus. X1 minus, minus minus plus, and y1, that's B, this is B, minus minus plus, whole square. A plus A will be 2A, square of that. B plus B is also 2B, square of that. So what does that sum up to? That is 4A square plus 4B square. We can simplify it. We could take 4 common, that's A square plus B square, positive square root. Taking square root of 4, that's 2 times square root of A square plus B square. So you can't cancel this. See, you could cancel provided. You can cancel square root provided these two terms, they are in terms of product or they are in terms of the quotient, not in terms of sum and difference. See, if you have AB, if you have A square, B square, square root of this. So this is nothing but AB whole square, positive square root. Here square gets rid with the radical sign. If you have A square by B square whole square root. This is nothing but A by B whole square root. Here this goes with this. Now if you apply the same logic to A square plus B square and you just cancel it, this is wrong. Or if this is minus, this is wrong. Now if situation is like this, if you have A plus B whole square root, yeah, you can cancel it. You have to be clear about this. Now we move further. Now second question is find the distance between these 2 points. Can you find the distance as for section 7.2? This is section 7.2. So there's a previous question, so there's a link. So I won't take it because you have to move on to that. Now, there's one important question which is based on the collinearity of 3 points. And we do this question mostly with the help of area theorem. Area result. That's the last exercise. Means 3 points are there. You are asked to prove that these 3 points are collinear. So I will take it once I start the area result. In fact, we could do it using the section formula also, and we can do it using distance formula also. Let me explain a little bit about collinearity of points. See, if you take 2 points, they are always collinear. Because as per Euclid, 2 points are determined by a unique line, 2 points. Now 3 points can be collinear or they can be non-collinear. Like there are 3 points, A, B and C. Now these 3 points are non-collinear. You join them, you get a triangle. Now if you take A, B and D, these 3 points are collinear. They fall on the same line. Now you can prove collinearity of 3 points using distance formula, using section formula, and using area formula. But as for area, it's quite convenient procedure as for area result is concerned. So I'm going to take it using that way. So we'll move further. We have question number 4. This is all about a triangle. Okay, see, a distance formula point is how we know that we have to use distance formula. Will it be given in the examination, use distance formula? Sometimes they could ask, they could just give a hint, using distance formula, find the distance between these 2 points. But always that's not the case. So we have to remember, we have to understand what are the types of sums in which distance formula is applicable. Right? Now, you have two different areas, like one is based on triangle and one is based on a quadrilateral. It could extend to polygon also, but as for grade 10th, you have a quadrilateral and a triangle. Now, you will be given a triangle whose vertices are given, all three vertices are given, and you are asked to comment on the nature of the triangle. Means you are asked to verify or you are asked to prove that the vertices, three vertices are given. For example, A, B, C are given. These coordinates are given like 1, 3, minus 1, 0, 7, 5, whatever it's. So 3 points are given. So you could have different types of questions which you can do using distance formula. You will be asked to prove that or verify that these 3 points, they form an equilateral triangle or a scalene triangle or an isosceles triangle or a right angle triangle. We have these 4 types of triangles. So this is the nature of the triangle. So you could do it using distance formula. I repeat, using distance formula, and in fact they won't ask in the examination. Like I have question number 4. I am being asked, check whether these 3 points, they are the vertices of an isosceles triangle. So this is on the nature of the triangle. Why isosceles triangle or a right angle triangle or a scalene triangle or an equilateral triangle. So how we do that? Using distance formula, you find all the 3 lengths. That means you will find length AB, you will find length AC, you will find length BC. It's quite obvious. If all 3 lengths are equal, it's equilateral. If all 3 are unequal, it's scalene. If out of these 3, 2 are equal, it's an isosceles triangle. And if square of one length is equal to the sum of the squares of the other 2, then it's a right angle triangle. This is all about triangle. Same is all about a quadrilateral. Means you have, that is my question number 5th as well as question number 6th. Vertices of a quadrilateral are given. You have to verify, you have to check the nature of the quadrilateral. Is it a parallelogram? Is it a rectangle? Is it a rhombus? Is it a square? We will work on that. But let me first take question number 3 to see if it's an isosceles triangle. My coordinates are, I will simply draw the diagram. This is question number 4. My triangle is ABC. ABC. My vertices are 5, minus 2. 5, minus 2. Then second is 6, 4. And my third vertex is 7, minus 2. What's the question? Check whether these 3 are the vertices of an isosceles triangle. So we will take the lengths of all 3 sides. So I will take the length AB using distance formula. So my distance formula is x1 minus x2 and so on. So move on to AB. So I'm going to AB. So this is x2 minus x1. I will just write now directly because we did 2 sums based on this. Now we are used to it. x2 minus x1 whole square plus y2 minus makes it plus y2 minus y1 whole square. x2 minus x1, y2 minus y1. So this is 6 minus 5, 1 whole square. 4 plus 2, 6 whole square. So what is that? That is 1 plus 36. And that is nothing but root 37. No need to evaluate. No need to find the square root of root 37. Don't waste your time in the examination. So let's keep it this way. Now let me move on to the other length, AC. AC is this. This is done. AC, distance between A and C. x2 minus x1 whole square plus y2 minus makes it plus y2 minus y1 whole square. x2 minus x1, y2 minus y1. 7 minus 5 is 2, square of that. And this is nothing but 0, so leave it. So this will be nothing but 2. Square goes with the square root. So my first length is root 37. My second length, means of the other side, is 2. Now what is left? BC is left. Apply distance formula. BC will be x1 minus x2 whole square. You have a choice, x1 minus x2 or x2 minus x1. x1 minus x2 whole square plus y1 minus y2 whole square. So that is 7 minus 6 is 1. 1 square is nothing but 1. Okay, let me write it 1 square plus, this is minus 6 whole square. That is 36. So that is 1 plus 36. That is root 37. So we have observed that 2 lengths, 2 sides of this right triangle, 2 sides of this triangle are equal. AB is equal to BC. AB is equal to BC. So it is an isosceles triangle. So we have verified. Now, applying the same logic, if you are asked a question, and I think it should be worth 3 marks, you are asked to prove that, to verify, to check that this triangle is the scalene equilateral, so you should be able to do it. Now we'll move on to a quadrilateral. So for that we have question number 5, but I need to first tell you how you identify if it's a rectangle, if it's a square, and so on. So I will first rub it. Now as for quadrilateral is concerned, what are the special types of quadrilaterals? You have a parallelogram, you have a rectangle, you have a rhombus and a square. Kite is also there. So let me take first parallelogram. Now how will you verify that the given 4-sided figure is a quadrilateral, which is a quadrilateral, is a parallelogram, or is it a square, and so on. Let me first write all of them. First I will take parallelogram, and next I will take rectangle, and third is rhombus, and fourth is square. Now we have studied in grade 9 different properties, how you prove it's a parallelogram, diagonals bisect, opposite sides parallel, opposite sides equal, opposite angles equal. So we are not going to do it in that way, because here you have simply lengths, you don't have angles as far as coordinate geometry is concerned. Now if you have a quadrilateral and you have to verify that it is a parallelogram, what you will show opposite sides should be equal. In a parallelogram, opposite sides should be equal. So I will write opposite sides equal. Opposite sides equal. And they are equal in a rectangle also. Opposite sides equal. So in a parallelogram, opposite sides are equal, same as in a rectangle. But what further? How they differ, parallelogram and rectangle? In parallelogram, diagonals are not equal, but they are equal in a rectangle. So opposite sides equal, and next thing you will say diagonals, you will verify diagonals equal. And here diagonals unequal. Diagonals are unequal. They are not equal. And here diagonals are equal. Just remember it. No work on angles, because the distance formula won't give you any idea about angles, what's the magnitude of angles. So if you have to verify, you have to show that the quadrilateral whose 4 vertices are given, is it a parallelogram? You will find the lengths of the opposite sides, they ought to be equal. Diagonals, if diagonals are not equal, then it's a parallelogram. But if opposite sides are equal as well as diagonals are also equal, then it's a rectangle. And what about a rhombus? In rhombus, all sides equal. So if all sides are equal, and same here, all sides equal. And what about here? Same as about diagonals. So diagonals are unequal. In rhombus, diagonals are not equal. But in a square, diagonals are equal. That means for all these 4, you have to work on the diagonals. But for parallelogram and rectangle, you have to work on the opposite sides. And for rhombus and square, you have to work on all the 4 sides. But all 4 sides are to be found. So that means if you have a quadrilateral, you have to apply distance formula 6 times. I repeat, if you have a quadrilateral given and you are asked to verify if it's a parallelogram, if it's a rectangle, if it's a rhombus, if it's a square. Sometimes maybe you will be asked to work on kite. What about kite? And what about trapezium also? Just what about kite? Are diagonals of a kite equal? They are not equal. But what are equal? Their adjacent sides are equal. See, you might have seen kite this way. These 2 sides are equal, these 2 are equal. But diagonals are not equal. And in trapezium, you have a special case of a trapezium where non-parallel sides are equal, but all 4 sides are not equal. And these 2 sides, they are never equal. then it will become a parallelogram. These two could be equal. Usually you have questions based on these 4. So that means when a quadrilateral is given whose 4 vertices are given, you find all 4 sides. That means you applied distance formula 4 times. Then find all the lengths. Then see out of this which case is appropriate. So maybe all 4 sides equal and all diagonals equal, square. All 4 sides equal, diagonals equal, rhombus. All opposite sides equal, diagonals not equal, parallelogram, otherwise it's a rectangle. So we are moving on to question number 5. So we'll take in question number 5. There's a diagram shown. In a classroom, 4 friends are seated at the points A, B, C, D. There's a diagram given. This is exercise 7.1, question number 5. 4 boys are seated. 4 friends are seated at A, B, C, D. Figure 7.8. Champa and Chameli walk into the class, and after observing for a few minutes, Champa asks Chameli. The 2 girls, they walk into the classroom. Champa and Chameli, 2 friends. Champa asks Chameli that, don't you think that A, B, C, D are the positions at which these 4 friends are seated? Champa asks Chameli, don't you think that A, B, C, D is the square? Chameli disagrees. So using distance formula, find which of them is correct. So there's a hint that you have to use distance formula. So 4 points are there and we have to fix the coordinates. So I will take, this is my A, this is my B, this is my C here, and this is my D here. So using the concept of coordinate geometry, we'll fix the coordinates. Now A is in, if you see, its coordinates should be 3, 4. Coordinates of A. So 3, 4, I will take coordinates of A. Now what about coordinates of B? See, B has coordinates 6, 7. See, as I said, run and rise. Starting from O, I have to walk 6 units and I have to go up 7 units, 6, 7. So 6, 7, these are coordinates of B. A, B, C, D. Okay. What are coordinates of C? For C, I have to walk 9 units along x-axis and 4 units along y-axis. So 9, 4. 9, 4. And for D, I have to walk 6 units along x-axis and 1 unit up. So 6, 1. 6, 1. So these are coordinates of A, B, C, D. We have to see that if this figure is a square. Champa says it's a square. Chameli disagrees. Let's see who is right, Champa or Chameli. So we'll apply the distance formula to find all the 4 lengths as well as the diagonals. So for square, all 4 sides should be equal. Diagonal should be also equal. So AB. This is question number 5. Okay. So AB using distance formula. AB. So x2 minus x1 whole square plus y2 minus y1 whole square. 6 minus 3, 7 minus 4. 6 minus 3 is 3 whole square. 7 minus 4 is 3 square. So that is 9 plus 9, that is square root of 18. You can simplify it. It's 3 root 2. Let it be like root 18. Now let me move on to BC. BC will be 9 minus 6 whole square plus 4 minus 7 whole square. x2 minus x1, y2 minus y1. 9 minus 6 is 3 whole square. This is also minus 3 whole square. So that is again 9 plus 9. That is square root of 18. So BC is also square root of 18. So we're getting one length square root of 18, other length also square root of 18. Let's move further. This is CD. CD will be 9 minus 6 whole square and 4 minus 1 whole square. What is that? That's 9 minus 3 is 9 minus 6 is 3. 4 minus 1 is also 3. So it's 9 plus 9, that is 18. So third length is also same. Third side is also same. So we're left with AD. What is AD? AD will be 6 minus 3 whole square plus 1 minus 4 whole square. And 6 minus 3 is 3. 3 square is 9. Plus 1 minus 4 is minus 3. Minus 3 square is 9. So all four lengths are equal. So AB, BC, CD and DA are all equal. So we have to further find the lengths of the diagonals. Now till this level it can be a rhombus also because all four sets are equal. So the decisive factor is to be given by the length of the diagonals. So let's find the length of diagonals. My one diagonal is AC, another diagonal is BD. So what is AC? I don't think we are going to do it here. Less space. So what I will do, I will rub this, then I will find the length AC and BD. But we have observed that all four lengths are equal. So we have observed that AB length, BC length, CD length and DA length, they are all equal to root of 18. Now we'll find out the diagonal AC, the length of the diagonal AC. What's diagonal AC? It's x2 minus x1, 9 minus 3 whole square, plus 4 minus 4 whole square, 9 minus 3, 4 minus 4. 9 minus 3 is 6 whole square, and this is nothing but 0, so that is nothing but 6. So diagonal AC is 6. And what about diagonal BD? BD will be 6 minus 6 whole square, plus 1 minus 7 whole square. This is 0 plus minus 6 whole square. That is root 36 and that is 6. So diagonals are also equal. So AC diagonal is equal to BD. So we conclude ABCD is a square. So Champa is right. So ABCD is a square because all diagonals, both the diagonals as well as all the four sides are equal. So that helps us to find question 5. Sixth is also on the same lines, but we have to name the type of the quadrilateral formed, if any. So what does he say? Name the type of the quadrilateral formed, if any, by the following points and give reasons for your answer. Let me take one part of it. So he says, see if these 4 points, they form a quadrilateral or not. And if they form a quadrilateral, tell us the type. Is it a square? Is it a rhombus? Is it a parallelogram? Is it a rectangle? So let's try one part. Rub it. Question number 6. Now my 4 coordinates, 4 points are, whose coordinates are given -1, -2. A is -1, -2. B has coordinates 1, 0. C has coordinates -1, 2. And D has coordinates -3, 0. Now it's not that you have to have the exact location of these points, because see, like this is in the third quadrant. This is on the x-axis. This is in the second quadrant. This is on the y-axis. No, sorry, this is also on the x-axis. So randomly just plot these points, not as for the exact locations concerned. So we have to see first if these 4 points, they form a quadrilateral. If so, what's the type? So I will roughly draw ABCD like this, irrespective of what figure it forms: -1, 2, 1, 0, -1, 2, and D -3, 0. So let's find the coordinates. We'll find all 4 lengths. Okay, AB. Now AB will be using distance formula -1, -1. Means x1 minus x2 whole square plus y1 minus y2 whole square. So what's that? That will be -2 whole square, -2 whole square. So AB is 4 plus 4, that is square root of 8. That is 2 root 2. So length AB we found. Let's find length BC. Length BC is 1 x1 minus x2, so it will be 1 plus 1 whole square plus y1 minus y2, 0 minus 2 whole square. That's 2 whole square minus 2 whole square. That's 4 plus 4, again root 8, same like this, 2 root 2. These two lengths are equal. Let's move on to the third length, CD. CD is x1 minus x2 or x2 minus x1? x2 minus x1, okay. CD, x2 minus is plus y2 minus y1, 0 minus 2 whole square. This is minus 2 whole square. This is also minus 2 whole square. That's 4 plus 4. So root 8, same, 2 root 2. It looks like that all four lengths are going to be equal. Till date, this, they are equal. Now AD is left. AD will be x2 minus x1 whole square. x2 minus will be plus y2 minus y1, 0 minus will be plus whole square. This is minus 2 whole square, that's 4. This is also 4. That's root 8. That's 2 root 2. So all four lengths are equal. It's like same previous question. Now diagonals are to be found and they will decide is it a rhombus or a square. That's my AC as well as BD. So all four lengths equal, 2 root 2. Now I'll find out length AC as well as BD. So we observe that AB length, BC, CD and DA, they are all equal to 2 square root 2. What's length of diagonal AC? AC will be x1 minus x2 whole square. See, x1 minus is plus y1 minus y2 whole square. y1 minus y2. This will be 0 square. This is minus 4 whole square. This is square root of 16. This is 0. 4 square is 16. That is 4. And lastly, diagonal BD. That is minus 3 minus 1 whole square. BD. x2 minus x1 plus 0 minus 0. That's 0. Okay. So this is minus 4 whole square. That is minus 4 whole square is 16, that's 4. So diagonals are also equal. So AC and BD are equal. They are both equal to 4. So we conclude that this figure is also a square. So it has 2 more parts. You can try it. Now I have 4 sums left and they are all based on a common concept, that is, there's a point whose coordinates are given or you have to find, maybe x is given, you have to find y, or y given, you have to find x. But there's a condition that this point is equidistant from some other 2 points. So 7th, 8th, 9th and 10th, they are based on the same logic. Let's see how many we are able to do. That's question number 8. Find the value of y for which the distance between P and Q. So P is 2, 3, 2, minus 3, I suppose, yeah. And Q is 10, y. Q is 10, y. So PQ is distance that's given to be 10 units. It's already given. Distance between P and Q is 10 units. So my PQ is given to be 10 units. But PQ you could find using distance formula. That will be x2 minus x1 whole square plus y2 minus y1 whole square, that equal to 10. x2 minus x1 whole square, y2 minus y1 whole square. 10 minus 2 is 8, square of that. This will be y plus 3 as it is. We have to apply a plus b whole square. That is 10. What should we do to the square root? We'll get rid of the square root. So squaring on both sides. So that would be 8 square plus y plus 3 whole square. If you square on both sides, you get this as 100, squaring on both sides. This is 64 plus apply a plus b whole square, a square plus b square plus 2ab is 100. A square plus b square plus 2ab. So that is y square, writing the standard form, plus 6y plus 9, 10, 11, 12, 13. 73 minus 100 equal to 0. So this is going to be quadratic in y. So 10 minus 3, 7. 9 minus 7, 2. Minus 27 equals 0. So you are aware of how you solve a quadratic equation. This is in terms of variable y. So once you solve it, you will get the value of y. That will be the coordinates of y. So I think you are in a position to do this. Then 9th is also on the same lines. See, I just read out the question. If Q has coordinates 0, 1 is equidistant from P and Q. P has coordinates 5, minus 3. R has coordinates x, 6. Find the values of x. So here also he is asking find the values. That means when he says find the values, so you end up with a quadratic equation. That's why you get two values of y. Same is in question number 9. You will get a quadratic equation in terms of x because he says find the values of x. Then also find the distance between P and R. Sorry, find the distance between QR and PR. So it's of the same format. Now question number 10th is you are asked to find a relation between x and y such that the point xy is equidistant from the point 3, 6 and minus 3, 4. So again 2 points given 3, 6 and minus 3, 4, but you are asked to find the relation between x and y. What does that mean, find the relation between x and y? It means you don't have to find the value of x, you don't have to find the value of y, you have to find a relation between x and y. That means an equation. So you will get an equation in terms of x and y because equation is simply a relation. So you will apply the same logic, my dear friends. So P has coordinates x, y, and A is given like 3, 6, and B minus 3, 4, but already given that PA equal to PB. What's the relation between x and y? So when you apply PA equal to PB, you get 2 square roots on both sides, then squaring on both sides. So you will get rid of x square and y square on both sides, if x square and y square on both sides, but you'll get a linear equation. Relation between x and y, you'll get a linear equation in terms of x and y. So that brings us to the end of distance formula. I hope things are clear. And in the next video, I'll be taking up the subtopic of section formula, that is exercise 7.2. Then we'll move on to the area formula. Let me see if I could finish that in one single video, section and area formula. So that will help us to complete the topic of coordinate geometry. I hope this video is useful to you. Happy learning, and we'll meet next time. Thank you.